Greetings to all and a warm welcome to all in Dr. Abha Chemistry पाठशाला. So आज हम फिर बात करेंगे उसी कंपाउंड की जिसको एक फिजिसिस्ट माइकल फैराडे ने आइसोलेट किया था कि डू यू रिमेंबर? ओके, हमने बेंजीन की फिजिकल प्रॉपर्टीज किया, हमने बेंजीन का मेथड ऑफ प्रिपरेशन किया एंड देन नाउ वी मूव ऑन टू द chemical properties of benzene. We did aromaticity of benzene and we do realize it is very difficult to mess up with benzene because benzene बहुत stable होता है. इसके पास तीन डबल बॉन्ड है ना? तो दिखाने को तो ये बहुत अच्छा एडिशन रिएक्शन दिखाता है, बट इट डजंट डू दैट. इट डजंट शो एडिशन रिएक्शन. व्हाई इट डजंट शो एडिशन रिएक्शन? इट ऑलवेज रेजिस्ट एडिशन रिएक्शन बिकॉज इफ इट undergoes addition, the aromaticity will be lost, delocalization will be lost, and benzene will not be that stable. So usually it prefers to undergo substitution. Okay, so let's think about it. कैसा substitution होगा? Electrophile आएगा या nucleophile आएगा? Okay, nucleophile will not come. Nucleophile will get repelled by the 3 pi bonds. So it is going to be the attack of electrophile. Also we'll have to make arrangements to generate an electrophile. See, something like which is very neutral, chlorine में से कैसे हम electrophile को generate कर सकते हैं? We can do it. If we take a Lewis acid which is an electron acceptor, वो क्लोरीन से क्या करेगा? इलेक्ट्रॉन को अट्रैक्ट कर लेगा. तो हम करेंगे आपकी बेंजीन के साथ very important substitution reaction. Of course, since double bonds are there, there is a likelihood that the benzene does undergo addition, although under very difficult conditions. So we will do some addition reactions. Of course, oxidation. Does cheminophore act on benzene ring? Does benzene undergo ozonolysis? Let's find it out. Over to the screen. Chemical properties of arenes. Let's go through the flow chart. Benzene and its derivatives primarily go through 3 types of reaction. First is Se+, that is substitution. S for substitution. E+ is electrophilic. They undergo electrophilic substitution. And halogenation, nitration, sulfonation, Friedel-Crafts, alkylation, acylation are the major 5 reactions which make the base of the benzene reactions. We'll study them one by one. The second category of reaction is addition. You all know benzene has got, guys, 3 double bond. If you look at benzene and its derivatives, it's got 3 double bond, but still it resists addition. It resists addition. I hope it is clear from my previous class that why it resists addition, so as to retain its aromaticity. Still under drastic conditions, it undergoes reduction, that is addition of hydrogen, and halogenation. Let's move on to the next, that is combustion. Let's move on to the next one, oxidation. We have normal combustion where benzene will give carbon dioxide and water. Then we have ozonolysis because double bonds are there. Let's see if it undergoes Bayes test, that is cheminophore alkaline. Does it break its double bond or not? Let's study that. We have controlled oxidation, and I'm sorry, this should be pyrolysis. This should be pyrolysis, okay? That is under high temperature, lysis, it breaks down into small components. So let's read that. So let's start doing them one by one. Benzene has got 3 double bond. So actually it should undergo addition, but it does not. Instead it undergoes substitution. And substitution also between electrophilic and nucleophilic, it undergoes electrophilic substitution because nucleophile gets repelled by the 3 double bonds. So among electrophilic substitution, the first one what we'll do, halogenation. We will be doing halogenation first. In halogenation, you can take chlorine or bromine, right? Any of these. And see, chlorine or bromine will not give electrophile because chlorine is a homonuclear species. We have to create electrophile. In order to create this electrophile, we need a Lewis acid. Now this Lewis acid will compel one chlorine to take electron from here, and then Cl+ will be generated. We will be doing mechanism separately. You can follow the mechanism, right? So you will have electrophile Cl+, which will get substituted on the benzene ring, and the byproduct HCl. So you get chlorobenzene. Exactly on the same lines you can get bromobenzene, right? Okay, but in case you take excess of chlorine, and in anhydrous AlCl3, that is where the electrophile is to be generated. Anhydrous AlCl3 means electrophile is to be generated. It is definitely going to be a substitution reaction. But all the places, we will get substitution on all the places, all 6 positions. And what we get is hexachlorobenzene. We get hexachlorobenzene. Okay, now the function of AlCl3 is to act as a halogen carrier. It creates electrophile and it takes it to the benzene ring. In case we are doing iodination, students, please mind it, in case we are doing iodination, we don't need a halogen carrier. But this reaction is not very useful. Why the reaction is not useful? And the reaction is reversible. So not of immense importance. And what we can do is, we have done Le Chatelier principle. If we remove HI, we can prevent reaction from going backwards, right? So how do we do that? We can prevent reaction from going backwards. So how do we do that? Very simple. We treat HI with any oxidizing agent like periodic acid to give you iodine. So now reaction will not go. Let's balance it out. 3, and here we get 5 or 1, 6. So this is going to be 3, right? We can use other reagents as well. We can use HNO3. We can use HGO. So here we get I2, and we get NO2. We get H2O. With Hg, we use HGO, which is an oxidizing agent. Again, we use HI. And here we get HgI2 and H2O. So now HI will be removed and we can use the iodobenzene produced. So shall I balance this reaction as well? Let me balance it. This is HI plus HNO3. We use 2 HI and 2 HNO3, and water is going to be 2 to 4, and this is going to be 2. N is going to be 2 again, and I2 is going to be 1. And this reaction is HgI2, so I have to put 2 here, and H2, I think this is balanced, right? So let's move on to the next one. This is a halogenation, and let's do sulfonation. Sulfonation is done in presence of sulfuric acid, very high temperature, fuming sulfuric acid, and we take SO3. So sometimes we call it as oleum, or you will see H2S2O7 written on the arrow. So this will give you benzene sulfonic acid, and you get water. Similarly, if you do nitration on benzene, you use HNO3 with H2SO4. This is known as nitrating mixture. Both of them together is known as nitrating mixture. And this nitrating mixture generates an electrophile NO2+, which gets substituted on the benzene ring. And you get water as byproduct. So this is nitrobenzene and water. Alkylation or acylation. In alkylation, we use alkyl halide. In alkylation, we use alkyl halide. And electrophile generated is alkyl. Electrophile generated is alkyl group. So you take benzene ring treated with CH3Cl, again in presence of anhydrous AlCl3. What does anhydrous AlCl3 does? It will help us create an electrophile and take it onto the benzene ring. And you will have toluene, and the Cl will react with the H plus, which you get from the benzene ring to give you hydrochloric acid. Let us do acylation. In acylation, what we do is we use acyl group. So we will have RCOCl. That is, we will have acyl halide, and the electrophile will be acyl group. That's it. This is acetyl. Just taken a particular example. Acetyl, you can have CH3CH2CO, any group you can have. So again, we start with benzene, reacted with acyl halide in presence of anhydrous AlCl3, and the electrophile generated will be acyl. Plus HCl. Going to be acetophenone or phenyl ethane 1-on. So these are the substitution reaction. Let's move on to the next category. First, let us do hydrogenation. We take benzene, we take excess of hydrogen, we take nickel, and very high temperature. Why do we need high temperature although there are double bonds? Because this is aromatic. This is highly stable, right? So we need to have high temperature to break the bond, and what we get is cyclohexane. No byproduct because this is a addition reaction. And in halogenation, what we have to ensure is electrophile is not created. See, if electrophile will be created, it will be substitution. So what we do is we ensure we take chlorine. You can take excess of chlorine if you want to break all the bonds. So I take excess of chlorine and I take very high temperature so that we get free radicals, right? But we ensure the absence of halogen carrier, because if there is a halogen carrier, it's going to be a substitution reaction. What we get is all the places the bonds are broken and you have Cl on all the places. So what will be the IUPAC name? Hexachlorocyclohexane. Right? This is also known as BHC gamexene. BHC is for, you'll be surprised to know, gamexene is a very important pesticide. Now it is banned in many of the countries, gamexene, because of the toxic nature. Or BHC stand for benzene hexachloride, but let me tell you, there is no benzene in the product. There is no benzene. It is cyclohexane, but इसका नाम benzene है because benzene के ऊपर addition होता है, combustion. So when you take benzene under very high temperature and pressure, right? So what you get is carbon dioxide and water, and the enthalpy of combustion is something like minus 3000 Kelvin. Minus 3000 kilojoule per mole, very high. And if you want to balance it, this is C6. Let me put the numbers. It's easier for me to calculate. Right? So this is C6H6. So if I put 6 here, now there's oxygen also, so double. So I will put 2 here and 12 here, and 12 2s are 24. So 24 and water also. 6 2s are 12. So yeah, 6 ho gaya, and this is going to be 24 6 30. So here it is going to be 30 means 15 here, right? So this is the first one is conversion, where we take free supply. Percentage of carbon is high, so it burns with a sooty flame. Next one, controlled oxidation. For controlled oxidation, the amount of oxygen will be limited. V2O5, vanadium pentoxide, at a very high temperature, say about 775 Kelvin. Right? So what actually happens is carbon dioxide is given out, water is given out, and what we get is, if you remember, this is malic acid. This is malic acid. When we further heat it, water comes out. You know, when there are two acids, what we get is acid anhydride, and then we get malic anhydride. Right? We get malic anhydride. So KMnO4 will give nascent oxygen, and this nascent oxygen brings about oxidation. But benzene does not get affected by KMnO4. If you take higher homologues of benzene, like toluene, isopropyl benzene, etc. Right? So presence of only one H has to be present to the carbon which is attached to the benzene ring, will bring about oxidation. There is a separate video on this. I am putting the link in the I button, right? Also, you will find it in the description box. Please go through that video, right? So even if there is one carbon, this carbon will give you benzoic acid, and this carbon which is separately attached will give you formic acid, which will further give you H2O and CO2. There are many other cases which we can do for methyl benzene oxidation. You can go through that video once again, right? In ozonolysis, this double bond will break, this double bond will break, this double bond will break. The single bonds will remain intact. So first let us draw the single bond. These are the single bonds, and the double bonds will give ozonide. Let me use blue color for this. This will undergo reductive cleavage. So the cleavage will take place from, what will happen is, wherever there will be double bonds, see, this will give a double bond here, 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 and a double bond here. I hope it's visible, and the outcome is going to be single bond, a double bond here, and a double bond here. Similarly, double bond, single bond, and double bond. Third one, double bond, double bond. So we get 3 moles of ethane 1,2 diol or glyoxal. Pyrolysis actually is heating the compound at a very high temperature, and it breaks into smaller parts.
right? That is how. Now here what is happening when we do the pyrolysis of benzene, we have done pyrolysis of alkane to give alkenes, if you remember, right? So when we take benzene, we take 2 moles of benzene, and then it is heated to very high temperature of 873 to 1073 Kelvin, right? And we take red hot tube, we call it pumic, or you can call it red hot iron tube. You know where else we use it? We use it in trimerization of acetylene. Abhi aapne reaction likha hai, right? So, and what we get is biphenyl. What we get is biphenyl.
So that was all about the chemical properties of benzene, and you do realize that now the reactions are becoming so repetitive. The reactions which we did in benzene, some of the concepts we've already studied in alkane, alkenes and alkynes. Of course, alkenes ke double bond or benzene ke double bonds, there are differences, but still there are some similarities as well. So we meet in the next lecture with a very interesting topic of again benzene. Till then, take care of yourselves. Bye-bye.